Hello, and thank you for joining today's webinar featuring Stiles Construction. Today's session will cover how the project teams at Stiles uses BIM data for a variety of workflows for improved project control. During this presentation, all lines will remain muted to preserve the quality of the recording. All questions will be addressed at the end of the webinar. If you have a question at any time, please use the question panel on the right side, and our team will answer them shortly. We will also have a recorded version of this presentation ready to share tomorrow. Now let's get started. It is my pleasure to introduce you to today's speakers, Assemble Product Manager Tim Kelly and Chris Lengiza, Construction Manager at Stiles. Go ahead, Tim.
Thanks, Samara. And today I'm going to be very brief and let Chris dive in here shortly. But before we do that, I want to make sure that for those of you that aren't familiar with Assemble, we have the opportunity to go through a brief introduction and quickly talk about the importance of data management for that application and how we're using BIM today. From there, Chris is going to dive into some of the workflows that he and Stiles are doing right now in their department and how they're utilizing it for estimating, scheduling, and production tracking. So a brief overview of Assemble. We are a web-based platform that allows you to access your Revit or AutoCAD information. So we're a published environment that you essentially extract all of the information out of that design tool, and you use the web to dig in, add attributes to your model, analyze the data, group it in different ways that you need to see it, and then share that information out with your project team. So ultimately, with a system like ours, you don't have to download other software for your users. They're just logging into a web browser. This company was created out of a general contractor, and I believe that the idea from the get-go was to be something that's simple to use. So many of the design applications for building information modeling have so many buttons and so many options and windows and pull-downs that it becomes really complicated to use. And our core concept is to make the experience easy and understandable and allow people that aren't familiar with BIM to get access to that data. So in general, that I think has been part of our adoption, and we're seeing great growth in our organization due to that fact that it's simple to get in and get the access to the information that you need. Some of the industry challenges that BIM is facing or that BIM is addressing is that, I'll talk about my history. I come from a general contractor, and I know when I started working as a BIM manager, or BIM coordinator at the time, we barely saw any owners require anything related to BIM. And then there was this kind of big uptick, and we've got to have something that's related to BIM, so we'll put in a specification that you have to deliver BIM. And ultimately, none of them really understood what that meant, or very few did. And so they're requiring something that was just very broad, and essentially you could address it in many, many different ways and not exactly meet the criteria or what they were really wanting. And now I see it that more and more owners are actually specifying the deliverables that they want on their project. So getting very detailed in exactly what they want to provide. And so through that, as a general contractor or construction manager, you need to have the capabilities to manage and deliver the data that they need to basically be a part of that work, of that project. I also know from my experience and when I was managing a BIM department, it's pretty difficult to get a team built out because resources are limited. That our team was always spread very thin on many different projects because we were essentially at one point in time the only access into that data. With a system like Assemble, you're actually allowing many users into the environment that they can manage the data that they need to see and utilize. So it's allowing better use of your VDC team or your BIM staff instead of doing every action for all the other users or consumers of that information. So, and I think with all of that, we're seeing a continued increase in the use and adoption of BIM on projects, and I think 2016 is going to be a great year, and beyond that, I believe will be even better. But with that said, I want to introduce and turn it over to Chris and let him talk about how Stiles is using this process or their process on projects. And with that said, Chris, you want to go ahead and take it over?
Sure. Thanks a lot, Tim, for the introduction, and I'll take it from here. So just a little history on myself. My name's Chris Langies. I am the director of VDC at a company down in Fort Lauderdale called Stiles Construction. We're part of a larger company called Stiles Corporation. We have a real estate group, we have a development group, architecture, property management, financial management, and assets groups as well. So we do a little bit of everything. So when I came to the company, one of my first things that I was always thinking about was how can I get more people kind of involved in the BIM effort and more people involved in the modeling in our company. And I came across Assemble about 2 years ago, and it seemed like a really good solution for what I was trying to do, considering it was completely web-based. I didn't have to worry about getting it on somebody's machine, and it was relatively simple to learn. It didn't have the learning curve that a Revit did that would require someone to know how to get in there, model, build schedules. So we kind of came up with this team mentality of using Assemble for kind of consumption of that information that a very select few were kind of authoring. So today I'm going to talk a little bit about, kind of our pre-construction process and how we're evolving. By no means are we all the way there, but we're starting to move down this path. We have a couple of people on our pre-construction team that are already involved in this process and have gone through this on 1 or 2 jobs now, and we're working to get the rest of our team brought up to speed as well. But in the past, how did we typically collect data? Well, we did it the way that everybody else did, right? Piles of paper, then maybe we moved to some sort of electronic documents and used a source or a software like OST to be able to do takeoffs. But inevitably, it was a pretty manual process, and all that information then was dumped into Excel at the end of the day. We took that information, we compared it to subcontractor bids, maybe we applied some unit cost to it that we had built up over the years, and we used that information to vet numbers, to put together thumbnail estimates, and to be able to give owners prices on projects as we approach them. When we came across Assemble, we kind of changed the way that we did things a little bit. We're still doing a lot of that paper workflow, but on projects that we're getting involved early enough, we'll start modeling right at the beginning. And the reason for that is we see that there's not necessarily always a huge time savings in creating the model versus just a traditional estimating process, but we get a lot more out of it. Not only are we going to get the estimate quantities, not only are we going to get some ideas about the constructability of the building, the logistics of the building, but then we're going to be able to pass that model downstream to our operations team to be able to be used for coordination, to be able to be used for the rest of our effort throughout the operations phase. So we still have that kind of workflow of we start in Revit. We are a Revit shop for the most part. Our architecture group is helping us out with that. They're actually generating some of our models now as well. We have a team of 3 or 4 modelers in-house, and we do outsource a lot too. So we utilize Revit to generate our models. We'll push them over to Assemble, and then the information will get right back to where the estimators like it, right back into Excel at the end of the day, that they can use it and manipulate it however they want. And that was a nice touch for the software, was that it got, at the end of the day, the information got to where we were used to manipulating it to create the reports that we needed to create the takeoffs that we needed to, and to be able to, scope our subs and to work with our subcontractors. The one other change that's kind of happened is we've kind of changed what we put the priority on. I mentioned that we build the model earlier because there's a lot more that we can get out of it. On the left, you see that the traditional takeoff process using maybe OST. Basically, at the end of the day, we get a marked up set of plans with some quantities. And that's really kind of all we get out of that process. When we go through the modeling process, we're going to get the model, we're going to be able to get our quantities out of it, we're going to be able to do our coordination with it, we're going to be able to get enough quantities and information on it to do some production tracking, to do some schedule projections, to do logistics. So it's a lot more information than we traditionally were getting, and that's why we decided to kind of push that up earlier in the process and kind of prioritize that above the just traditional takeoff to get the data out of the plans. So how do we get started with this process on a project? I think what's important to know is that, it's a team approach. We don't have just one or two people doing this. It really is a group of people that are involved. It involves some people from our VDC department, some people from our pre-construction department, usually an operations person or two are involved, and we kind of get them together at the beginning of the project to come up with a plan. What is it that we need? What data do we need out of this model? And that data may change throughout the course of the project. Early on in schematics, we might be looking for less detailed data, so more whole scope project data, things like skin of the building, gross square footage, overall metrics that we can use to put a price to a project. We also need to know when do we need it. Okay, when is it that we need to deliver these different quantities? At what stage of the project do we need to deliver them? And then how do we break it down? Everybody estimates a little bit differently, so this is where having the actual estimators on the job involved early will tell us, like, how do we want to break down this data? Do we have different areas of the building that we need to provide an estimate different for? Do we need to provide it by floor? Do we need to provide it, rentable square footage versus gross square footage versus net rentable square footage? How are we coming up with those numbers, and how do we want our data to be broken down? And by having this kickoff meeting early in the project, that really allows us to get the team together, have these conversations before we even start modeling, because that's when the changes are easy to make. As you start to go down the road in the way that you model things, sometimes it's tough to go back, and it will cost you a lot of time to have to make the changes later. So here's a couple of examples of one of the projects that we did, and we really just started with a mass model. Literally in Revit, kind of masked up the building based on the floor plans at schematic design, used it to generate things like gross square footage, exterior skin. We got some general concrete numbers out of this, total unit counts out of this. And what was important is that we were almost continuously pushing this model to assemble. So we didn't wait until necessarily we had the entire project finished, fully modeled, with all the detail in it. We pushed it real early, basically with this massing model. That was our first push, and then we continued to develop that model. We then focused in on items that had the most risk, or things that we might want to control. On this particular project, it's a 37-story mixed-use project. It's a concrete structure, so we were really focused on the concrete shell package. We were considering doing things like buying the concrete ourselves, buying the rebar ourselves, detailing the rebar ourselves, potentially even providing some labor numbers for the rebar. So those were items that we wanted to focus on early, so that was the next step in our modeling. Then we started to focus on items that would repeat. Because this is an apartment building, we have units that repeat over and over again. So by basically modeling what was the typical floor that started at the 11th floor, I was basically able to generate basically floors 11 through 35 because they were repeated. So once I did one of them, I was able to push a whole ton of data over to assemble. And then finally, filling in the detail, getting all the nitty-gritty stuff that completes out the model, that brings it up to the standard of the drawings level that we were at. And we did this throughout a process that ended up kind of spanning over, it was almost about 11 months that we were doing this. We published the model, I think, 38, 39 times to the system, people to be able to utilize. So once we got it into assemble, what do we do with it? Well, in order to kind of make it easier for our estimators and our pre-construction managers and our team members to work with it, we kind of set up some kind of standard views for them. And we did that by utilizing the data that was already in our model. We broke things down like, just show me all the concrete. Okay, that was one saved view that we created for them. Just show me all the glazing on the building. Show me some of those big picture items that have a high value towards the job and drive the cost of the project. We were able to save those views and then utilize them every time we published the model, which is great. We're also able to transfer those views over to other projects so that they were used to seeing those 5 or 6 standard views that we had for them that they could go in and jump into on any project. This is all done by basically a set of filters that is using the Revit data that is built into the model to basically either hide or show different types of elements. And it becomes pretty easy, especially we started this project actually on the old platform of Assemble, and then they released Insight, and it got a lot easier for our people. In the old platform, you kind of needed to know a lot about kind of how families were named and category naming in Revit. But in the new, it's basically, do you want the walls? Then you click on the walls radio button. If you want different structural columns and beams, you can highlight those elements really quickly. So that was a really great change that helped speed up some of our effort as well. So then we realized that we needed to be able to push a lot more information back to the modelers. The pre-construction managers were wanting to break this model up in many different ways. One of the ways that specifically, because we were looking at concrete, was the strength of the concrete. And just because the designer had said that, you know, all the floors needed to be 6,000 PSI concrete doesn't necessarily mean that's how we were going to build them. You know, there were a lot of factors that had to deal with it, you know, between puddling, between schedule and how we wanted to schedule the pours. We actually ended up changing some of the strengths of the concrete throughout the building, so we needed to estimate it that way. And we were trying to find a way for us to communicate that information back from Assemble into the model. And one of the ways that we found worked great was shared parameters. So there's a lot of reasons to use them. You know, when an architect updates a file, do I need to start over? Well, not necessarily. If you're utilizing shared parameters, a lot of that information can be pushed back into their Revit model so that it stays with the original model, and when he updates the model in Assemble, it stays with it. You know, if you don't have access to Open Revit and you want to make changes to an element on some of the properties of it, so you can either sort it or you need to communicate back to the person who's actually using Revit to model the building, you can use a shared parameter. We use quality control metrics, we use commenting in Assemble that pushes back to our modelers. This helps us keep up with the changes. This helps us kind of put our own logistics and our own constructability on the building as we progress through the project. All this data is then kind of synchronized back and forth between Revit, between Assemble, Excel, Navisworks. We can basically update these shared parameters in any of those platforms, and they're going to push back and forth so that they're useful to us throughout the project. So just a little bit of how we kind of create these shared parameters. I'm going to go through this pretty quickly. After the webinar, they're going to send out a handout that basically walks you through this step by step. So if you've never created a shared parameter file before, it can be a little daunting the first time you do. It's basically a giant text file that if you open it up on its own, it just looks like a bunch of gobbledygook, and you couldn't really understand it if you wanted to. But Revit knows what it's looking for. So the way you do it is create these shared parameter files in Revit. They're on the Manage tab. You can click on the Shared Parameter button, which will allow you to create your shared parameter file for the first time. I created one that specifically just handles my Assemble parameters. I have some other shared parameters files that I also use, so this just separates all of those shared parameters out from the rest of them. From there, we need to actually create the individual shared parameters, and just think of them as properties that you can go ahead and edit in Revit or Assemble. And they have different types. Typically we use the text type or a yes and no type. Those are the two most common ones that we use. So as we create those, you can create as few or as many as you want. Typically, these are some of the common ones that we use. Structural ones, we use a structural group. So we like to group our structure into different types of elements. Vertical concrete, horizontal concrete, walls, shear walls, stairs, miscellaneous concrete. So we can break our concrete takeoff down into a much more granular level just by grouping it by using a shared parameter. The other thing was concrete strength. You heard me talk about sometimes we were changing the concrete strength from the design model. So our modelers had followed the plans and they had modeled everything per the design, but we realized we were going to bump up the concrete strength on some of the floors, on some of the columns, on some of the areas. So we needed the estimators to be able to have that ability to change that parameter. We also use things specifically for quantifying the model. buttons. They're basically a radio button that says, has this item been taken off, and then who took it off, who included it in their estimate. So we can track that the items have been included in someone's estimate. And if there's ever any question about, well, is that really the right person to include that element, you can see who did it, and then they can have a conversation if there were multiple people working on the project. This actually also allows us to kind of create a view of items that haven't been taken off, basically filtering out everything that has already been taken off. And the idea is you start with the entire model, and as you classify items and put them into the groups that you want and put them into the places that you want, they actually will disappear off of your screen because you've taken them off. And then the last place that we use shared parameters a lot is on the schedule side, and this goes into the operations side of the work, but basically tracking things like the installation date, what activity ID on the schedule does it relate to, what WBS group does it relate to, and then we're going to use it to do some look-ahead. So I'm going to show a little bit of that towards the end, and how do you group it into a look-ahead group so you can do some visualizations. So once you've created those shared parameters, the ones that you want, the next thing you have to do is actually put them into your project. And the easiest way to actually do that is to put them in a blank template project. Because of the way that Revit works, it doesn't allow you to just batch import a whole bunch of shared parameters. Case used to have an add-in that did it, but now Case is no longer. So if you didn't have the add-in before they were left, you're not going to be able to get your hands on it. So the easy way to do that is to put them all into one template project. You add them individually, one at a time. A couple of important things to note here is where you put them. You can see I put a highlight box around group parameter under. There's kind of two schools of thought here. We either put them usually underneath the Other tab, or we put them underneath the Identity tab. We tend to put them all under one place so that when we're in Assemble and we're looking for them, they're all stacked up right next to each other. The other thing you want to do is you basically want to assign them to every single category in the model. That way they're available for anything that's in the model that you could possibly put in there. And you don't have to worry about, oh, well, I forgot to put the structural group to the structural column. If you just apply it to all, it makes it a little bit simpler. So once you have that template blank project with all the parameters that you want into it, you can use the transferring parameters from templates, a template project, into your project. And all you're going to do is basically go into the Manage tab again, transfer parameters, project standards from one project to another, and only check off the project parameters box. That will basically bring over all of those and merge them with yours, all of those specialty, all those shared parameters that you had created, and bring them into your existing Revit project. Now the reason that this is great, first example, let's say that you're working with an architect and he's already gone down the road and done a whole lot of his modeling, and then he brings you on board and you're at the, let's say, the DD phase, and you want to start pushing, having him push his models to assemble for you. Well, if he pushes his model to assemble and you don't have any of the shared parameters, you're not going to be able to do some of the workflow that you want. Well, you can simply send him your blank template file, and then he can just transfer those project parameters. Hopefully he's willing, and most architects have been willing to do it, to bring it into his file. It will add those parameters to all the elements in his model, and then you'll be able to go ahead and utilize them in the next time he publishes to assemble. So that's really nice to know that even if you're not the author of the Revit model, this is a way that you can utilize those parameters. Now, if you don't have Revit at all, you're going to have somebody create these parameters for you. If you want to use mine, they're also linked in the handout to a place where you can download all the project parameters that I've created for this workflow. So once you get those project parameters and we've gone ahead and we've pushed our model to assemble, now we can start manipulating the data. We can see that over on the right-hand side of our screen under our properties, we start to see some of those shared parameters start showing up under identity data and other. Things like activity ID, things like concrete strength, our taken off button, and these are all editable within Assemble and then can be pushed back into the Revit model for us. So we can manipulate them within Assemble and we can filter by them within Assemble, which is great. You can see that I've filtered my model here by structural group. So I've got it broken down, separated by CMU, columns, concrete walls, foundations, miscellaneous items, and then I have a not assigned group. So really those are all the things that I need to focus on. I need to figure out what those elements are and put them into one of my standard shared parameter groups. Okay. One of the great things about the shared parameters in Assemble is they remember the text that you've already put in. So as you've started to work on a project, you don't have to type in columns every single time. As soon as you start that C in, it's going to bring up any of the shared parameters you've used the first time, which is great because the first person who goes in as they start creating them, it helps avoid those typos. It helps avoid people creating column versus columns. They'll be able to bring up the ones that are already in the model so that everything is kind of grouped into the same group, and it'll remember everything that you had put in there before. So that's really its feature as well. So now let's say that we want to go ahead and group our model by shared parameters like we had done before. That this is kind of, our model. We're going to go ahead to our group by option. You can see I've kind of highlighted that on the left. And then we're going to go ahead and create a new basically grouping. We're going to call it structural group. And then on the left will be a list of every property that is associated with the model. Just use the search box, search for structural group, and add it to that grouping order. Now you can go a couple levels deep if you want, or you can just keep it really simple and group everything by structural group. You could group everything by taken off and not taken off. You could group everything by who took it off, for example. Whatever works for you in your workflow to try and make sure that all the elements in the model are covered and make sure that they're all basically put into one place for you. So once we have that kind of grouping done, now we can go ahead and start filtering out some items. So this is what I was talking about before by using a view that basically only shows the items that haven't been taken off. So what I've done is I've gone ahead and added a new rule under my Assemble rules that basically says show me only the items that have a property of taken off as no. So basically the box is not checked. So as I create that view, basically what I'm seeing is all the items that I've not taken off yet. And basically anything that I have taken off should disappear for me. And as I assign a taken off parameter to, they should also disappear off of my screen. So this is one of those filtered views that we put in basically every one of our projects right at the start so that our estimators and pre-construction managers can kind of go through, and as they classify the items, as long as they check off that taken off box, the items will kind of disappear off the screen from them. And there can be multiple people working in that view kind of at the same time at their own machines, and things will be disappearing off of each one of their things, their computers every time that they refresh. So one of the other notifications that we basically came up with was we realized that we're not perfect. We're not robots. We do make mistakes in modeling. How can our pre-construction managers communicate back to us either items that they see as constructability issues or items that they see that may be errors in modeling, errors in the drawings, so on and so forth. So we kind of came up with this idea of a QC comment or a QC item on a model element. So what happens is that the pre-construction manager is navigating around the model, interrogating the model for the data he's looking for, and say he notices something. For example, this column does not look like it goes all the way up to the roof like it's supposed to. So he said, okay, well, let me make a note and send it back to Chris so that he can fix that in the model and make it right. So what he does, he comes over into the QC comment area and he types in and says, this wall should go up to the roof, I think. I'll double check it, and when I take it back down to my model, I'll be able to see that, and I run basically a specialty view for myself called QC comments. Show me any of the items that have a QC comment that's open on them. So I can kind of look really quickly, and then it will basically highlight the elements that are there that I have to address. Now, we've since added another box, which is basically a QC comment checkbox on whether or not that QC comment has been taken care of so that we can make sure that we take care of all the items that we have. Okay. So now that let's say we've done our estimate, we got ourselves a job, and now we need to transition over to the operations. And this is what I was talking about before, where I wanted to make sure that the model continued to live on. And how could we use this model and all these quantities in our operations phase? And we found some really good ways to hand it off and utilize it with our field staff. With the help of Tim, and he can expand on some of these, so I'll hit on them briefly, and when we get to the questions, I'm sure you guys will have a lot of questions on how to to do these, but we use them for look-aheads. Basically, our 3-week, 6-week, depending on who you are and how you do your look-ahead scheduling, we came up with a way to basically create a look-ahead visual schedule in Assemble. What we did is we were able to take our model and basically classify elements and associate them with either work breakdown structure items in the schedule or activity IDs in the schedule. And what this allowed us to do is basically kind of take it out to Excel, compare it to our schedule, and if the date that that element was supposed to start happens in the next 3 weeks, then it would basically say that this item is to start in the next 3 weeks. If it was to finish in the next 3 weeks, then it would classify it as to finish in the next 3 weeks. And then the other option would be that this is to this item should be completed within, or it expands this 3 weeks, so it's going to be continued to be worked on in this 3 weeks. And then we just run a filter to color code these elements in the model so we can visually show our team what the work that they're supposed to be working on. So for example, this was a foundation system on one of our projects, and we were able to kind of use this as we were testing it out on. The items in green are the items that are to start this week. The items in blue are the items that are to finish in the next 3 weeks, and the items in gray are items that have already completed. And you get a little bit more than just that visual. You also get the quantities of that amount of work. So for example, the concrete guy says, okay, great, I see that there's how many foundations, and really quickly he can get the count of them. Okay, how many cubic yards of concrete am I going to need to get delivered, over the next 3 weeks? Well, I'm going to need, 196 yards is supposed to be finished this week. So, okay, that gives me an idea how much concrete I'm going to need. It's a really good tool for them to basically communicate with the team, communicate with our superintendents, and get an idea of really the quantity of work that they're approaching going forward. You can see it a little bit better here in this blown up view, but like I said, we're using those shared parameters to link to an activity ID or a work breakdown structure. We're then creating a custom view that filters out start, finish, or behind schedule. And then we use Excel basically to write an if statement that groups the items into the correct category. Basically, it's a combination of an if lookup and an if statement that puts a value into a cell. And Tim can help you out with that. He helped me write the first one, and once I got the first one down, it was pretty easy to go ahead and edit. So once we got that down, we kind of realized that, well, maybe we should do a little bit more tracking on the quantity of work that's going in place. And we wanted to do some production trending and see how we were actually producing, how much work we were actually putting in place. So we took that kind of same example, and we wanted to see how much was getting installed on either a daily basis or a weekly basis. We kind of wanted to go on just a weekly basis because we thought it was a little simpler. So what we did is we used shared parameters to tie those elements back to those same activity IDs and work breakdown structure. We basically spread the quantities over the duration of the schedule. So if we were supposed to pour zone 1 foundations in 5 days and it was 200 yards, then we knew it was supposed to be about 40 yards per day. And then we used Excel to kind of graph the work in place versus the early and the late start. And you could do a really simple check of your production to see if you were actually getting what you needed to. So basically all I've done is you can see that the foundations here that are highlighted total up to 63.19 cubic yards. Now if that was the amount of work that I put in place that day, I knew if I was supposed to be getting 40 yards per day, that was probably pretty good. I was actually getting a little bit more production than I was supposed to get. When we wanted to go a little bit further, and this is where Tim was helping us, and we were kind of progressing this idea a little bit more, of kind of charting this over the course of the project. Basically, on a weekly basis, you can see the yellow line is the actual work in place, the blue line is the early start, early finish, and the red line, the late start, late finish. This allowed us to kind of say, basically, as long as that yellow line stays between the two lines, we're in the good. If we're rapidly approaching the red or rapidly approaching the blue, we might have to make some correction. Now everybody says, well, if you're rapidly approaching the blue, you're going to be way ahead of schedule. Well, that's good as long as we know it and we can plan for it. So if we start to see a sharp trend upward in our actual work in place because we're getting more production, maybe the guys brought on another crew, whatever may happen, it gives us a couple weeks to look ahead and say, okay, well, it looks like we might need another trade a little bit sooner than we were expecting because we're going to beat that end date. And it kind of gives us a visual representation of how we're ending up on the project. This is still kind of in what I'll call an alpha or a beta stage on our projects. We're using it more in the simplistic fashion right now of just how much did we install today. On that project that you guys saw earlier where we were doing a heavy amount of takeoff, we're actually in the ground, getting ready to start put piles in place right now. And our plan is to basically track all of the concrete because we are buying the concrete on that project. So we're going to use that to track our production and our concrete of basically everything that's poured. So we're going to make sure that we put an install date on basically every deck, every column, every beam that's in that building, so we have a really good idea to compare our delivery tickets over to our actual work in place. And then the last tool that we felt that was really useful for us in the field was model comparison. We know that we're going to get changes throughout the project, and sometimes, you know, it's not clearly communicated to us exactly what has changed. So our modeling teams will then go ahead and, if you're in the case where the architect's actually giving you the model, this could be a very quick process of just comparing the previous model to your existing model. Or if you have to have your team update the model, I think it's good because you're also going to double check it again to make sure that all your coordination still works, but you'll also be able to check the quantities that have changed. And really it's pretty simple. A quantity of what everything was in basically the original model, a quantity of everything that there was in the new model, and then whatever the variance was, up or down. And basically you can click on any of those items and highlight them in the model to see exactly what changed. You'll be seeing a case study that came out with us that we used this on that Max Miami project to help basically mitigate some contributing factors to almost $1 million budget increase. And it really helped us communicate with the team and really dive down and figure out what was going on. Why did all this stuff get added? Okay, some of it got added by the building department. Can we question it? We were able to win some of those battles and get that budget back down to where we needed. So it was a really good story of being able to kind of communicate exactly what changed. The architect on that job was not modeling the project. We were doing all the modeling for them, for the project. So it kind of was a really, you know, good visualization that we could utilize. So kind of, you know, some of the, just to conclude on that, I think one of the things I've gotten out of this whole workflow that we've kind of developed is using Assemble makes it a little bit easier for your BIM guys to talk to your estimators in my way, my line of work. You know, the modelers are going ahead and progressing and pushing through and getting the model done, and they speak in terms of Revit and family types and things like that. And then you can push it over to Assemble, and it's kind of a workflow that they can understand. It ends up in Excel. It breaks things down in familiar names like walls, ceilings, columns, beams, floors, things that they can look for, and they can classify it however they want without having to know how to build complex schedules in Revit. So it's a great handoff tool there. And then to continue to utilize that model in Assemble throughout the rest of the project and be able to utilize it for production tracking and all those quantities that you've already generated, don't let that data die. Let it continue to use throughout the project and become useful and let you manage your project and manage your risk. I think Tim has a few other things to say, so I'm going to kind of turn it back over to him, and then we'll go ahead and fire off for some questions.
Thanks, Chris. And yeah, just to add a little bit to that, you're talking there at the end about, you know, schedule data and adding the information in and having it all right there. And from my experience, it's all of those data sets, it's about how they relate. And all the conversations that, from my end, have been very valuable are the ones when you can say, how does this information relate to this information? And ultimately, when I've worked with project managers or estimators or superintendents or whoever it might be, it's all about getting that information in their hands very quickly to make decisions. So in all of this, it's just being able to quickly get to that data for these guys. So that's about all I have. I appreciate you, Chris, for going through all this so quickly. And so I think at this point, we'll turn it over to Samira to kind of push out some questions.
Thank you so much. We actually do have quite a few questions that have come in. I believe, Tim, you will be the best person to answer this one. One of our attendees wants to know, can you elaborate on what models can be published, just Revit or contractor fabrication models as well?
Yeah, I'll answer it this way. Right now, we, in our development efforts, we had focused initially on Revit and then worked on AutoCAD for a bit to bring in the data there. And I know many of our users actually import data through Revit by means of IFC files or other DWG or AutoCAD formats and use Revit as the publisher to get into Assemble. But I'll let you know in the very near future we're going to be working on other authoring platforms as well. We haven't organized which one's first and then second, but they're going to be coming very soon.
Perfect. Now, this is actually for Chris. What software was the original massing model done in?
So the original massing model was done in Revit. We probably could have used SketchUp, but we used Revit just because we were already there and the plugin is there right to go to Assemble. So that's what we did. We just used typical massing in Revit and pushed it right over to Assemble.
Now, do you do this on all your projects?
Good question. No, we don't do it on every project. Obviously, we pick and choose the projects that we're going to do it on. We do a pretty wide array of project size, anything down to maybe like $500,000 sometimes, all the way up to $100, $150 million projects. So we tend to target the projects that it's going to have the most value on. A lot of the mixed use, high-rise projects seem to lend pretty well. So once we know that we're going to model the project anyways, we will, if we're brought in early enough, we'll start to attack it from the beginning with Assemble.
Perfect. Now, who inputs the WBS or productivity information to the Revit model? How is it done faster than the traditional methods?
Okay, so basically the way that we ended up doing it was we used Excel, and I kind of just wrote some filters to be able to filter down everything that I needed to put a WBS to. So we pushed the Revit model to Assemble, exported all of our elements out to Excel, and then I could use filters to basically filter everything that was by floor, by whatever we needed it to be, and then I could kind of just use the fill down mentality to be able to push that in through Excel, and it's much faster than going into Revit and clicking on a whole bunch of items or trying to select a whole bunch of items and then trying to change it in there as well. That works as well because that allows you to kind of use your selection box method of grabbing elements as you need, but it is a little bit easier, I think, in Excel. That was how we ended up doing it on this project.
Yeah, and I'll add to that real quick and state too, from the teams that I've worked with in projects, sometimes we have our BIM team that takes care of it all. That essentially you're putting in a WBS code or an activity ID into the model objects and then associating all the other scheduled data based on that. Or I've had field engineers or project engineers that have the ability to help out with that. But in general, it's not really replacing a traditional schedule management method. It's augmenting that process. And as I mentioned before, having related data sets connected all through this and then a visual manner of looking at it is really what's beneficial here. And so it's taking that traditional schedule management and production data and incorporating into this so that you have very tightly associated the quantities and all the other estimating information or whatever other data sets you've added through the course of the project.
Thank you, guys. Next question. Does Assemble have an alternate to shared parameters that makes this easier?
Yeah, so I will, I guess, go ahead and jump the gun and provide you guys with something that we're working on right now. With our next release of our software, you'll have the ability to create or add what are called Assemble properties at the time. And essentially those are based in our platform, and whether you publish a model with shared parameters or not, you'll have the ability to add your own data sets that are outside of that, the model properties. So as Chris was mentioning earlier, with shared parameters, you have to create those in Revit. Or sorry, project parameters anyhow. You create those in Revit, and then if you get new versions of a model, you have to synchronize those back and then publish them again. But with assemble properties, those will be persistent as you publish new versions of a model. So if I associate a cost code or something of that sort to model components, then every time I publish a new version of that model, I will be bringing those data sets forward.
All right, thank you. Another question regarding shared parameters. Do you need the shared parameters to be in the published model, or can they be in another model published to the same project?
Okay, yeah. So they need to be in the model that you're publishing to assemble. Basically, by pushing that one model with the shared parameters, it would only have those parameters attached to that model. So if you push, say, 3 models to assemble, and one of the 3 models had the shared parameters in it and the other 2 didn't, only those elements that came from that model would have those shared parameters available to it. Now, Tim just basically told me that my workflow is garbage because they've got a new, better way to do this.
Not garbage.
In a new release. But it sounds like it sounds like those assemble parameters are going to be awesome, because it will certainly save us a lot of time of communicating back and forth with teams to try and get information into the Revit models.
Next question. What scheduling file formats does assemble read?
Assemble doesn't actually read any of the schedule file formats. We're using Excel for that. So Assemble's ability to go back and forth with Excel via CSV format is how we were getting all that schedule data in. So we were using P6, for example, and basically we extract that out to a CSV file. We then bring our Assemble data into that same under another tab, and then write some lookup statements looking for that information. That's kind of how we were doing it. So it's not actually, Assemble's not actually doing the heavy lifting there. It's really Excel doing the lookups and the heavy lifting there, and then pushing it back in to the elements via that Excel file.
Great. Now, will the next update for Assemble involve other modeling software format, such as Tekla?
No, that's not going to be in the next update, but when we do have something in a time frame, we'll provide that to you guys.
The workaround we've found for that is to go to, I know it's not perfect, but to go to IFC and then bring it into Revit and then push it to Assemble. Unfortunately, it's a manual process, but that's what it is as of today.
All right. Question for you, Chris. You mentioned that you guys are tracking or planning to track every concrete pour to match the delivery tickets. Does that mean that you are going back to Revit and slicing up the slabs and beams and walls to what you actually poured?
So that's actually a great question. So as part of that early on team meeting and conversation, we actually broke all that stuff down the way that we were going to pour it when we originally modeled it, to save us having to go back and break all of that down as we were going through the project. So we kind of, when we teamed up with, that's why we brought that operations person in and even got some sub input, we broke that stuff down the way that we think it's going to be poured. Now, that doesn't mean that there might not need to be a few things that are changed, but the heavy lifting has been done already early on in the project. So that will save us a lot of time for sure. I think one other thing, I'll just mention this because I saw a question that popped up that we didn't quite get to. Somebody had asked, why we modeled it and didn't use the designer's model. So this ties into that last question. We modeled it because the designer actually didn't model it, but even in some cases we may model it anyways because of those factors. Things like breaking the model up the way that you actually want to pour it, putting the logistics and the actual, the knowledge of how we're going to build it into the model. So we'll sometimes build a model even though we already have one.
Great. Next question for you, Chris. What are some of the biggest challenges that you have faced implementing this with your pre-con team?
Yeah, probably the biggest challenges that we had to face when we were trying to get people on board is, just believing that the numbers we were going to get out of the model were going to be as good or as accurate as they could do. And on this project, we actually kind of simultaneously did a traditional takeoff. We simultaneously did our model-based takeoff, and we had our subcontractors doing their takeoff. And at the end of the day, when we compared those three numbers, we were all within 1% of each other on concrete volume, which is pretty darn tight. And I was the lowest, being the model-based quantity. And we pretty much attributed to the fact that I was about 1% lower to the way that they were calculating waste versus the way that I was calculating waste. I kind of argued that the amount of concrete that I had would be the actual amount of concrete in the building when it was all done, and that the amount of concrete that they had would be the amount of concrete that you would need to deliver to the site to actually build it. So we were so close that we knew that our numbers were good. If we were off by much more than that, I'm not sure that I would have gotten that buy-in from them. So it was nice to have that exercise that now I think we have we have some faith in the numbers that are coming out of the model.
Great. Thank you so much. And we'll go ahead and actually end at this note. And, just want to take a minute to thank you, Chris, for joining us today and sharing your usage with the team. It was very much appreciated. And attendees, thank you so much for attending today's webinar. We really do truly appreciate you spending some time getting to know more about Assemble and Stiles. If you guys have any follow-up questions, just feel free to reach out to us and we'll make sure that all of your questions are addressed. And, definitely continue to join us in future Assemble webinars. Thank you.